Hello, we are Team 3 introducing our final product, the Meet Me Now Android application. Our ultimate goal for this project was to develop a service that, although based on a simple concept, could provide the foundation and potential for larger scale expansions and more elaborate implementations in terms of independence. Keep that in mind, we worked to create an application consisting of distributed peer-to-peer information exchange, so independent of a centralized server, and Wi-Fi direct connectivity, independent of an internet connection. We also chose to incorporate a location service with a compass navigation feature and pop-up message notifications on the front end for a more user-friendly experience. Early on, we decided that our skills challenges would be the Wi-Fi Direct Wireless Standard and API, as well as the implementation of test-driven development throughout our project. The basis of the scope of our application is its peer-to-peer architecture. Within this architecture, each device is able to act as a server for others, which allows the sharing of resources, in this case, GPS location. We use the Wi-Fi peer-to-peer API to facilitate setup and communication within our peer-to-peer network. We implemented a layered architecture consisting of the UI communicating with the application layer, which in turn communicated with the routing layer and then on to the network layer. Another component in the scope of our project is our bootstrapping mechanism. The peer discovery process consists of locating new peers, which are Wi-Fi direct enabled devices in range, introducing new peers to other peers within the network, and using multicasting to notify all peers in the network of these new peers' information for updating of their local list of peer mappings. We employed a geo-routing algorithm with greedy forwarding, where each node forwards the message to the neighbor that is most suitable from a local point of view, and this process continues until the message has propagated to the destination. The most suitable neighbor is the one who minimizes the distance to the destination in each step. As you can see by the green path in the image shown here, nodes who are within 200 feet of the source, user D, are considered its neighbors based on the connectivity range of Wi-Fi Direct. Despite the fact that there are other nodes closer in range to the source instead sends to the node who is closest to the direction of the destination, user O, on the far right. Also note that some nodes are not connected at all because the range between them is outside of the limit of Wi-Fi Direct. The messaging layer sends a packet from the source node to a neighbor using Wi-Fi Direct as the communication channel. Wi-Fi Direct devices are able to connect to one another without the need to go through an access point. Our location service utilizes the device's GPS location to facilitate routing of packets as well as location of the desired user using the interface shown here with dynamically updating compass navigation. Our functional testing consisted of test cases to satisfy the requirements for the UI, the location service, networking, and the logic of the application, which was performed on 2 to 3 devices at a time. We selected Wi-Fi Direct in an attempt to learn more about a newer and less commonly used form of communication. It also went well with our emphasis on independence and possessed a connection range of about 6 times that of Bluetooth, which was another communication method that we previously considered. The use of this technology proved to be a great learning experience, but the fact that it consisted of many restrictions in terms of its operation and stability, in addition to its lack of detailed documentation, made basic operations much more complicated throughout our development. In addition to these difficulties that were faced, testing proved to be challenging in certain areas as well. Unfortunately, our restriction to only a few compatible Android devices in our possession hindered our extensive plans for testing. We were able to develop and employ tests to drive the development of the routing layer, but test-driven development of the network layer was not very feasible in our case due to the need for multiple devices, multiple threads, and network communication. Our team was composed of 4 members, 3 in Pittsburgh and 1 on the Silicon Valley campus. We had meetings 1 to 2 times per week, depending upon availability and critical tasks. We also met with our project mentor, Jeremy, every 2 to 3 weeks for updates and to get any questions that we had answered. The main tools that facilitated the development of our project are listed here, where each played their own part in helping with communication, collaboration, and scheduling of the project. If we had the opportunity to do things differently, we would likely implement a more structured meeting schedule and work according to a more incremental task schedule. All things considered, we were able to create an application that delved into and pushed some limits of a new technology. We were able to do most of what we set out to do, all while learning about and getting hands-on experience with various components, operations, and communications within distributed systems. If there were more time in the semester, our focus for future work would consist of detailed user registration, social features, and increased incentives for research sharing and cooperation amongst users at a high level. At a lower level, we would have put more effort into implementing fault tolerance within the network and performing more comprehensive performance testing on many more devices. We would have also added a security component to provide encryption when transmitting messages through the network, and also optimize the routing algorithm and location sharing mechanism to deal with any quality of service issues. Overall, our application solved a simple but relevant problem for users and reached our goal of bringing people together one meet at a time. Thank you for listening to our presentation, and special thanks to Professor Nace for the opportunity.